So following on from the last video, we added login to the application. So now from anywhere in your application, you can do ioc.log.log. And we also added some color. So if we just run this, you'll see we've now got this color. This color comes in from an extension. So if you go to Tools, Extensions, and you search for VS color output, I think it's called, and install this one. You don't have to, but this is the extension we've made the color work with naturally. Otherwise, you just get the text, not the color. So now we can log to console, debug. I think those are the two we made. Let's just check. Yeah, the console and the debug. We're now going to write to file. So in order to write to file, we need to actually pad out the application a little bit more first and actually make a file manager to read and write to the file system. So that's what we're going to do in this video. One thing I've added in advance, just because I don't want to waste time explaining and writing this code for a simple single task and trying to explain all these specifics. I can do this potentially in a separate video, but it's just off topic right now for what we're trying to do. So we have here a class I've added, so you can just pull this from the source code, called async_awaiter. And you've seen in code we've done a lock. And this basically prevents anything more than one item from running this code while there's a lock. So if you call add logger 6 times, all on different threads, the first one will hit this lock and then go inside, and now all the other 5 threads will sit and wait outside until this is done. So this basically makes sure this is thread safe. You know, only one thing can ever access this at a time. Now the trick comes where this is synchronous, so it's not returning a task, it's not inside and await, it's not asynchronous. So it's a synchronous task anyway, or a synchronous function being run. So it's a different kind of thing than when we have a task. So if we're looking at any function where we have a task in the application, like just the animation, say, where we have this task, the caller needs to await the task for it to complete, otherwise it will carry on without it. And this is just asynchronous development. So it bubbles up to the point where you know, this caller is then calling async, even though it's void, meaning that the thing calling do animation won't wait for it to finish because this is only awaiting itself. So then these callers won't await. So this will hit here, tell it to do an animation and carry on. But that's kind of slightly off topic, but basically you've got synchronous and asynchronous tasks, and in general asynchronous, you know, run off to the side, if you will, unless you await them. So you can't just use a lock on an async, is the bottom line. You can't just say inside this asynchronous thread we did, you know, lock and then you'll see this complaint, basically, cannot wait inside the body of a lock statement. So once you do lock, you can't then use asynchronous code. So what I've done with the async awaiter is allow you to do this bit, the lock. And instead of doing lock, you can do await async awaiter, and it's in there, dot await async. And then what this now does, instead of passing in an object to lock, I've simply passed in a string. So you just make a unique string. So this could be, what you could do is say name of, and then this function. You just got to make sure that, you know, the key there, the string, is the unique thing, so that anything accessing this same string, you know, anything saying await async with the exact same string would act as if you're locking the same object. So you'd replace that there. And then in here is your task to actually run. So this is where you then do your asynchronous task, like that. And then there's also an extra option that you can't do with a lock, and this is potentially allowing more than one element through. So you could have a lock that, let's say, 3 or 4 tasks to run at the same time, but then simply waits otherwise. So by default it's 1. So then this will just go inside here. And basically that acts as like a lock. So this will await, just like anything else in the await statement, and it won't get to here until it's done. And this will sit and wait. If 6 threads hit this at the same time, asynchronously, 1 would get in, do this task, which could go on for a lot longer, and the others would sit and wait until it's done. So that's the point of the async awaiter, is to simply allow you to lock asynchronous threads. And like I say, I could go over this in another video, but the key to it is using the semaphore slim, which is it's basically an asynchronous locker. And then when we call the async await, there's one to get a result and one to just run a task. We lock ourselves first using a semaphore for our own awaiter to make sure this call itself locks correctly, because we're checking if there's already a key that we've passed in. So we kind of self-lock, check if there's a key. If not, we make one and add one. We then release the lock on ourselves, so it frees up the call. Then we get the semaphore for the specific key we passed in, and we wait for it to be finished. Then we run the task that it's expecting, and when the task finishes, we release the lock. So that's kind of how it works in a really quick overview. And I've also added a logger using our IOC logger if anything crashes, but then to carry on throwing, don't just catch the error and ignore it, allow it to propagate up, but at least make sure we logged it. So I'm not getting into great detail on this, but you can either read the code and comment and I'll reply, or I'll potentially do a future video on it. But ultimately, all you need to know is when you want to do a lock on an async thread, that's what we'll be using. So that's that little bit out of the way. Let me just make sure this file hasn't changed. So we've done that. Now we want to log to a file. We'll need to start with something that can write to files before we can log to files. So let's go ahead and create a new folder and call this file creatively. I've already got one called file apparently. Include the folder. And now in here, add a class. We'll call this file manager. Then we want to add this to IOC. And then a user's commented on a new shortcut. I delete the unused using statements. You can actually press Control or G, which I didn't know, which is cool. So that's a lot quicker. So we'll have a file manager, handles reading, writing, and querying the file system. This will want to have an interface of what we want to do. So it will be in IOC interfaces, and let's add a new class there called iFileManager. And this will be public interface file manager. We will copy the comment. And in this file manager, what do we want to do? We will have, just put one in for now, I think. We'll have a task. Write all text to file, say. Path and the text. And we can have, we don't need to put all, just write text to file. It'll be async because it's a task. Path or text or path. Don't know which way around to put those. Probably text, because we're saying write text to file. So to kind of keep it in order with the name of the function. So text path, and then we'll do a boolean for if we want to append data or not, and we'll default it to false. And that gives you the ability to, write to the end of the file or simply overwrite the file. Writes the text to the specified file path, or specified path, specified file. And well, that's it really. Don't want to go too complex. Text to write, the path to file to write to. There's a lot of twos in that sentence. The path of the file to write to. If true, writes the text to the end of the file. Otherwise, overrides any existing file. So that's the function we want to implement. Copy that, paste that in, make it a public async task. And now we want to actually do this code. So one thing we want to start doing now we've got the logger is thinking about catching all exceptions everywhere in the application, logging them correctly and recovering however we like. Because that's, again, off topic and really a separate video, we'll do exception catching later. So I'll just put a to-do here to add exception catching. And then we're just not going to bother with exception catching for now. Then we want to lock this call because we're dealing with a file, a specific file. So we want to make sure only one task can access the file at the same time. Otherwise, you'll get a system error that you can't do that. So I'll use this new async awaiter. And we don't need to return a value because basically if it succeeds, it will work. If it fails, we want it to crash and bubble up. And then we handle, the thing calling this then handles the crash. See if it's an expected crash, and we don't know how the caller wants to behave. If we were to return a boolean, simply a success or failure, that's not much information. So if it failed, well, what did it fail on? Then you have to start returning a boolean and then passing in a ref for, say, an error, which you can't do in async anyway. So that'll complain that you can't pass a ref in. So then you'll be stuck with them potentially making a tuple here that returns a boolean of success and a string of result. And then it just starts getting messy like that. And then what's a string error going to do for the caller function? How is, say, when we make unit testing, how is unit testing going to make use of a string? How is it going to know if it failed simply because the file's in use? It's not descriptive. It's not in any way helpful. So we don't just want to return success or failure. We want it to work if it succeeds and crash if it fails. And then in the crash error codes that we make, we can be very specific to why it crashed. And then unit testing and users and our code can handle that much better. But like I say, exception handling we'll do next, not in this video. So for now, it'll either work or the whole application will just crash, is basically the point. So the async awaiter will await. We just want to await a task. We've got no result, so it's the await async. The key wants to be unique, so we could just pass the path in, but really, what if something else is handling a path? What if we've got a delete file path or something else? So what we'll do is do name of, and then this function, and then plus that path, just so it makes a string that says write text to file async, and then the path itself, so it's unique. So that will lock any caller that calls the write file to async, or to be honest, because if we want to delete a file, write a file, we actually want it to be the same file that we're locking. We only want to ever perform action on one file at a time. Let's change this to file manager. And then every call inside of file manager that deals with a file will make this same key using this kind of, specifics. We should also normalize and resolve path potentially. So if somebody passes in a path that says C test some file, and another one passes in C test some file, then that's not, it's going to resolve to the same thing effectively, but our lock won't work. And, we want to normalize it so that you'd basically have this. So we'll add normalizing near the end, or we'll just chuck it in, in the next video as part of the exception catching. But basically, it pretty much looked like path equals path.replace / with backslash, and then potentially trimming the ends off. We have white spaces either side and doing an absolute path, but you don't really want to. That's not really normalizing. Absolute path is resolving. So there'd be a normalize, which would be that, and then there'd be a resolve, which would do a path. What's it called? Get full path, and that would resolve, any relative paths inside there. So we'll make that the end potentially. But what we also want to do here is this would be a switch based on which platform we're on. So if we're on Windows, you go to backslash. If we're on Mac or Linux, you go /. But again, we'll come back to that. But let's work through this first. So we haven't normalized the path, but we will do. Then you want the task to run itself. So then we'll just make a anonymous lambda function there. And now it's expecting a task to run. And in here now, so we've locked the file, lock the thread to this file, so only one method can act on file. That's a bit of a long, nope. Lock the thread, lock the task. Simple enough, because we know what we're doing, we're locking to a single caller. Now in here, because we are, the reason I'm making this a task as well is because this is an interface that we can replace in the future. And if we don't start doing asynchronous stuff, and then in future we move to UWP and their file management is all asynchronous, we wouldn't then be able to call this and await it correctly. You get yourself in a mess. So really we want to start making all kind of calls and all functions asynchronous. And then if we simply want to run an asynchronous, or if we then want to run a synchronous call, which is what we need because we have, say, file.write all text, you can see it's just void, it's just simply you call it. So that's a synchronous call. If we want to do that, but inside of this asynchronous call, all you have to do is return task.run, or await task.run because we've put the async there. So you then do task.run and then you run your task in here. So it looks like a little bit of extra bulk this is, but this is so that in future, if it did become asynchronous, say we then had a function that was actually awaiting here, like say, I'll just chuck task.delay, but say this was getting the file stream and it was awaiting, obviously this would be here, then you wouldn't need the task.run. You'd just then do that and then do your file.write all blah, blah, blah. So it's all based on if you need asynchronous in the future, we have it available in the interface. And then our unit testing can also handle that. So we want to be asynchronous because everything going forward becomes asynchronous. It's the, kind of the new way of doing things, so you can correctly await and handle tasks in a non-locking synchronous fashion. So turn or run the synchronous file access as a new task. And that's just simply because it needs to be, because this is an asynchronous locker and the interface is asynchronous, as we mentioned. So we've done that. We also want to, here is another note we'll do, a lot of stuff to come back to, add ioc.task.log. Not log, got log in my head, task.run. That logs to logger on failure. So another thing you have to be aware of is when you have a task, and the way that we handle this is we're going to crash. If anything goes wrong, we'll crash. We want to really, the caller of this should do a try, catch, and log the error. But say this is an asynchronous call to write text to file. And say in our app here we were going to use that. And we just did, we just have to make one for now, just to show you. So if we were then calling write text to file, it's going to complain for one that we're not asynchronous, because we haven't got an async here, we're not awaiting, so it's going to warn us that this will pass through, which you don't always get that warning. It depends where it is and what it's doing. Like certain places it just won't complain because it knows you're synchronous anyway. But you get this error, or this warning rather, if you just ignore it. What this means is it knows that this thread has called this, but we're not awaiting it. So ultimately that means that if this crashed, if we then threw an error here, this task itself would crash, which would crash this because it's awaiting the task, which would crash this caller thread. But the problem is this caller thread is off. It's not in sync with this synchronous thread. So that boils down to meaning if we had a crash in here and we weren't awaiting, then that error is gone. It doesn't exist, it won't be found, it won't crash your application, nothing will happen. So to show that, we could actually do throw new argument exception. And if we run this now, and we see here, and we see here and here, and then we run, you'll find we get to here, so we call it, and now you see it's step past perfectly fine, and the application will carry on. We then throw here, which bubbles up to nowhere, it's disappeared, and now we carry on with the application, and the application runs. Then, because I've added a logger here though to our, and this is why I've done it, to our async locker, this is why we've got the exception appearing, because, you know, I've added it to our logger. But you can see the application's running. So if this was a release application and, you know, a user's using it, or all your users are using it, you'd be unaware that something's just gone wrong. And that could be an important thing, and usually is. So if it's just failed to save the user's settings, or you've sent a message and it failed silently, and the user thinks they've sent a message, it's not good. So the lesson here is really to make sure we log and catch, or at least at bare minimum, we log the errors so they're not silent and they don't just disappear into nothing and we're just unaware of them. And when you work on tasks and you start doing this async task, it's very, very easy to simply not await one of the tasks or to do a task.run to purposely get off sync. You're in a synchronous thread and you want to run something in the background, you sometimes just do a task.run to break out the way of it. But then what that means is if that task ever failed, you're never going to know about that error. So again, slightly off on a tangent, but then this note, if we make ioc.task.run, then instead of just doing task.run, what we do is do a try, this would go inside, a catch exception, and then we do ioc.logger.log, and we'd log the exception, so at least, and then we'd throw to carry on. And then if anything did crash, at least we'd have it in our log file, regardless of whether our code awaited or not. So it's just that extra bit of backup that if things start going wrong silently, we have some log somewhere to, you know, debug the issue. So that's what we'll do after there, for that reason. Even though this will technically log, we want to get rid of using task.run everywhere and make sure we always call our IOC task run so that we have some kind of logging baked into the, you know, it's just a fallback, basically, a safety. So finally, we bake down to the simple task of writing a file. So we want to write this text to a file, and that's the easy part. So write the log message to file. So we've done the interface so that we can inject it into IOC. Then we've implemented it, we've got the function, we've locked it so that a single call will only ever get in here. And then because we're actually synchronous, we've jumped onto a task to make it asynchronous for now. And then finally, the actual work involved here is just make a file stream, we'll cast it to a text writer, so we can just call .write and send in some text. We want a new stream writer, and we'll open the file. So we open the file stream with the path, and we expect it to, now this is, you can see we've got append. So this will say, opens a file if it exists and seeks to the end, or creates a new file. So that is if we want to append. So we will have append file mode dot append. Otherwise, we say we want to, I guess, create the file or override it. So that will be specify the operating system should create a file. If it already exists, it should be overwritten. So that's the one. So basically, if we want to append, we'll open it as an append. If we want to, otherwise, we want to create and overwrite, it's that one. So this opens a file stream. Then we pass that into a stream writer because that expects a stream, so that we can write to that stream we've just opened. And then we simply cast it to a text writer so that we have the .write function on there. So finally, we can then do file stream .write, and now we can simply pass in the string value as one of the overrides, and that should be all there is to it. So that would be the text value. The using, all the using statement does, if you don't know, is disposes of the variable inside using. So this statement here is exactly the same as doing var file stream equals this, var.write file stream dot dispose. But slightly different, because what it'll do is do a try finally, basically, to make sure that it will always dispose even if this crashes. So a finally statement means that if you try to do this and obviously that would be there. If you tried to do this and it failed or crashed, you haven't caught the exception because we haven't put a catch in. But disregarding that, either way on success or fail, this will always run. So no matter what happens here, once we've created it, it always gets disposed. And that's all a using statement does. It does exactly this. This is exactly the code that runs. So that's just a shorthand way of making sure we dispose of this file stream once we're done. So that will write the file. And that's it. So that's the file manager. So if we go to IOC now, let's get this chucked into IOC. So we will have a file, UI logger, then we'll have file here. A shortcut to access the file manager. File. And then we want to go to, where are we? The app.xaml. In here, we want to move that one up. We want the logger to come first. Then we can bind UI. Let's bind the file after the logger. I think that's fairly low in terms of its high priority. It's low on the order. We want it to come in pretty quick. Bind a file manager. So now we pass in a new file manager. And now everywhere in our application, we can do ioc.file to write to file. So if we did ioc.file, write text to file, some text, and we do tests.txt, not sure where this will go. I think it will go to this folder. So we will see. So if we run this, we write some text to file, and have we gone here? Nope, so we will probably have gone to either one up, nope, or we've gone to the bin output maybe. Depends on where the default thingy is, basically, the default path, because we've passed in a relative path. I cannot see it anywhere. So, did we succeed for one? Information application starting. Set to statement. Go into the statement. Nothing actually run. So, oh yeah, we didn't await it. So as I was saying, this is how easy it is. We've called that function. Yeah, there's no warning that we need to await it. So we've hit here, but we haven't awaited it yet. So this is an example of exactly where I was saying if this function crashed, it wouldn't go anywhere. So the file doesn't exist yet simply because we haven't actually run the function. It's gone asynchronous. So we hit there and now hits here. So now when we write the file, it should appear, I'm guessing, either in here. Nope, or in here then. It must be in here. There we go. So there's the test file. And there's some text. And then we might hit it a second time. No, there we go. So if we were to now pass in, say, the append into here and say, let's append the text to the file. So we'll just say append true and say some other text. And this will appear on the same line, but now if we run the application and then check out the file, we should have now some text, some other text. So we can see the file, write to file is working. So we can do this now wherever we want to write to a file. So that's the file manager side done. We've added the thing there. We should also, when we come to exception catching, which again is the next video, we want to wrap everything everywhere. So like even the startup call, you'd actually end up doing a try and a catch around the whole thing. And then logging the error or displaying it. You know, we can't recover from that if the application failed to start, but we could at least either write to a log file, but it might be a log file that crashed. So in this specific instance here, where we're unsure of anything, we'd just explicitly type some code that maybe displays the error message straight to the user, so they can, you know, raise the bug to us. But again, that's the next video. We don't want to go into that in this one. So we've done all that. The only thing we now need to do is to make a file logger that then makes use of this file writer, and we can add it and then log to files. So if we go to logging and we make another implementation, call this file logger, and then we get rid of that public class file logger, iLogger logs to a specific file. Control dot to implement the function, and in the log here we want to add a public string file path to this logger, the path to write the log file to. So that will get set up. Logger methods. And then we also want the constructor. And in here, we want to always pass in a file path because we need to know where we're logging to. Otherwise, we can't do anything. And then we just set the public property to that so that it can be changed afterwards and accessed publicly as well. That's the constructor. And now the log. So again, here now we boil down to ultimately log into a file. We mentioned that we should try catch everywhere. Again, this boils down to exceptions. So what would you do if the file logger failed? We wouldn't necessarily try catch this call. We'd want to try catch at the uppermost levels. So you don't want all your code to have try catches in every function. That's not what I'm saying. It's more about that everywhere that then is the top level. So like the application is the top level. So here you'd want to try catch, and then anything inside there doesn't matter because it's caught. And then when you do specific calls, like inside of, say, a click event on your view model to change to another page, you'd want to try catch that command. And then if that fails, log correctly. But again, like I say, whole new video. So in here, we're not going to try and catch any errors because ultimately our log factory would be the one to catch any errors inside of the log here. So it would lock them for each one. It would do a try and catch inside of here and log out to, it would do its own logging, because the one key thing is if the logger itself fails, you can't log the error. So you have to have some real low-level code that simply should never fail and just does a basic logging, which would probably be either directly to the user or to a console, or however we want to do that. We'll come to that. So now to log to a file, we can do ioc.file .write text, and the text would be the message plus, I'd say, an environment dot new line, so that each message goes on its own line. The path would be the file path that we should be logging to, and append should be true. So write the message to the log file. And now we want to make use of that file logger. So if we go back to here where we make the log factory, we do a base log factory, which already contains the debug output. And then in here, we also want to, you can't do it that way, can you? You can't initialize that way. We could technically pass in, allow this to pass in a new constructor. I think we'll do that. So a base log factory that accepts, say, an array of iLoggers. So it'd be iLogger array. And these would be loggers to add. Constructor with extra loggers. Loggers to add to the factory. On top of the stock loggers. already included. So this would then be loggers dot for. In fact, can you do a for each on an array? I don't think you can. No. We can, thinking about this, we can pass this in as the default constructor. Just simply pass it in as null by default. Oh, move that up to there, get rid of that. So we still have one constructor then. So add the console logger, add any others passed in. And then we just do if loggers. So if we actually have some, for each logger in loggers, add logger. Like so. So if loggers isn't equal to null. And this would add each logger. So now what we can do, and a bit easier way of keeping it in a kind of single line, inside of here we just do new array, and we then pass in a new file logger. Pass the path in for now. So this would then create a base factory, and I don't know whether we can shorten this anymore. I don't think we can. I don't think we, not unless it's come further. No, so that's the shortest way we can do that. So create a new array and then pass in the file logger. So that's how we pass in one. And then you just pass in another with, you know, say there was two. You'd pass in another one like so. And that'd add two of them. So we add the file logger, and then the key here now is it's expecting a path. Where do we want to make this log file? So this will boil down again to something else to do. So to do. And this will be add application settings, so we can set edit a log location. So we'll do this in another video. For now, we'll just literally put it in the relative path. So it will go where we originally had it. For now, just log to the path where this application is running. And it's as simple as that. So if we now go to, this is where we're running from, we delete the test. If we just run this, it should now bind. We don't actually, oh, we should have an application starting actually. So this is now up and running. We should have a new file called log, which we do. And you can see it's now logged to a file, and there's a new line ready for the next log. Does that have the time and date? No, it doesn't. So the one thing we want to add to there is, and I thought we'd added that to all logs, is the time and date for, you know, the log messages. So I guess that depends on if you want that everywhere, or whether we add it to the file manager, you know, like the file log. So we could specifically say in the file log here, we want to write get current time. Current time equals, and we can have it with the now time is basically in your current machine's local language, so whatever your machine's set to. So I'm in the UK, so that's be UK time. If for whatever reason you wanted the universal time, so it's the same anywhere, like say you're doing it based on searching or filtering or, you know, comparing, UTC is universal time. So it's, we'll use the local time for a log file, and we'll do a toString. And let's see if I can remember the string value. I think everything, you've got day, month I think is the capital. I always get this wrong. And year, so that would be like day, month, year. So in order for it to sort correctly, you'd have year first, month, day. And have minute, hour, second. And maybe that's correct. It's just complaining just because of spelling. I've just got a spell checker in here, so I think that's just complaining because it thinks it's a spelling. Yeah. So let's just hit that and let's see if that's actually right. So the current time is like 9, probably somewhere around 9 in the morning. Let's see where we've hit. We have, so the month is 12, the year is 2017, the day is the 6th, that's correct. 48 wrong. That would be, not sure, 48, 9, 15. Well, we are 9, 48, 15. Oh yeah, it's right then. I just need to make sure I put the hour and the minute the right way around would help. So hour, minute, second. So that should give us, a current time correctly. So then we have the full sorted date and time. So we will now append that to the log. So what we will do here is make a new string. We'll put the current time at the start, which will always be the same length as well, which is handy. And then the file path. Hang on, I've done this the wrong way around. The messages at the start. It goes here by the message. So with that, then the message, then new line. So now the file logger has got the time. You could also set a Boolean here if you wanted. So public Boolean log time. If true, logs the current time with each message. And again, you could put this in the base log factory and have it logged everywhere. Or you could do it individually. Makes no difference. We can tweak this as we go, however we want. And by default, I'll have this set to true. I want to log the time. And then we have, we will do log time, question mark, all of that. Or rather, log time, question mark, would be current time. Which I'm getting confused now. We want to go into here. Really, this whole thing. Let's make it cleaner. Let's move this out. Var time log string equals log time, question mark if it is. Then we want the current time. Otherwise, we just want a blank string. And then all we have to do is pass that variable in here. So there we go. Right, the message. And this would be prepend the time to the log if desired. Now if we run that, and the application spins up, we now go to the text file, and we now have the time of each log, which makes more sense, especially in a file log. So that's really the file logging done. Let's go back to a few things. Prepend, I thought was a word. Prepend, I'm sure prepend's a single word. I'm going to make it a single word. So we are in core. Let's right click. What you can also add as well, which I find handy, is extensions installed, and have a look for Visual Studio spell checker. And then this highlights the purple things in your comments to make sure you don't miss typos. If there's certain words that we use as developers, like prepend, I'm sure is a singular word, I'm going to make it one. You can right click on your project, add, and then spell check a file, and go to ignored words and add whatever word you don't want to be flagging up like prepend, and save the file. And it won't show instantly. Sometimes just closing and opening the file's enough for then it to go away. But then it keeps your spell checking correct, like this SS as well. It's just annoying, so we'll double click and add SS because that's for our string, and then close and open that, and it should go away. Did I not save, or did I not add? Okay, it's not adding to the... Can't add two letters. Okay, can I add it through? Didn't know that before. Let's just go and edit this manually then. See if it'll work that way. Now does it work? No, it just completely ignores two letters. Okay, so we won't be able to get rid of that little thing, but I'm not too bothered about, that being in there. I can just do ignore all in the global the global file, I guess that'll work. It's a different configuration, but it's not specific to your project, it's specific globally. I think that might be a bug in the spell checker thing, that you can't add 2-letter words unless it explicitly tells you. So that's all spell checked correctly. So there's also a way, when we type things like to do, like this, there's a reason I do exactly this, capital letters and then a colon. And it's because you can pull them up as lists. I've just got to find out where. And I'm guessing it's in maybe, where are we? It's something like tasks in one of the windows. I haven't used it in a long while. Task list there, Control/T. And now you can see throughout your whole project, you can see our to-dos and where they are. So now we could use this to flick through and go add exception handling, which we want. So normalizing. So we can add the normalizer, but again, we want to make this useful everywhere. So I think the file manager should have the normalize path. So we'll go into here. That for a fact we know isn't going to need to be asynchronous because it's simply messing with a string, and that never is. You can make a smart judgment that is not going to be asynchronous. So this is happy to just be a normal function with a string, not a task string, and we'll call this normalize path. And then the path will go in. Normalizes a path based on the current operating system. The path to normalize, and then we will copy that entire thing and we will paste it here. Public normalize string, and then we'll simply do a switch on, and I can't remember where. That was a bad one to check for. Just checking for the runtime that I know we've used somewhere else. Sure we have. Have we never switched for an operating system yet? Oh yeah, we are in, I'm forgetting. We are in core here. So I know this UI only works on Windows at the minute, but that's the point of the core is now .NET standard. So this will work on Linux and Mac. So we should start switching for which OS we're on. So OS architecture, we switch on. And then we check if we're on, not the architecture, we want the platform. Is OS platform. So we can't do a switch on that. So instead we'll do if the OS platform is OS platform.windows, then return path.replace any /, and this is going to be used specifically for files because we're in file manager, so URLs don't matter. So basically on any path, we want to replace a / with a \. And we also want to trim both ends to make it blank. And what's it complaining about now? Expected a closure of what? Oh, the top if statement. Otherwise, we will presume, well, we know then we're either on Mac or Linux right now. So if it's that way around, then it's the exact opposite. We want to make any \/ /. So if on Windows, replace any / with back. If on Linux Mac, replace any, I should do that instead actually. Replace any forward with back. So that's our normalize code. So then in here we can now normalize path. And we could also do, no, let's leave it there. So we'll just do normalize path. And then we want to, we don't need to resolve path here, but it will help with the locking in case somebody passes in a relative path that boils down to the exact same path. Resolve to absolute path. Resolve path. And same again, file manager, we will add resolve path. Now this doesn't matter which platform you're on, it does the same because we're already calling a .NET Core built-in function. Resolves any relative elements of the path to absolute. The path to resolve. And absolute. Then we will place it there. We also want to wrap. Oh, no, we don't need to. Public string. Right, and then to resolve the absolute path, you simply return path.getFullPath. And that's it, because we're calling a built-in .NET standard function anyway. So now we've normalized, resolved, exception catching as next video. We can do the ioc.task.run. We can also just double check this works. And we've passed in a relative path, but now we should be able to see it in there. We've got no forward slashes, so that won't change. We're resolving that now, and you should see now it's now resolved to my exact folder. So now when we do the async await, the key is now going to look like that. So you know, it's got the file manager name prefixed, and then the whole path. So no matter how you access this file, it's been resolved and made absolute. So it'll always be, there's no other way to point to this file. So you can make sure this lock always works on that file then. So that's that. We can now add we'll add the ioc.task.run as well, just so that when we want to call, say this was being called this task.run outside of any kind of await, we also log the error. So for that, it's just yet another IOC interface, so that we can again replace it for unit testing or anything else. And this will be task manager, I guess. And then we can always add anything else that is to do with tasks. Handles anything to do with tasks. Nice and simple. And we will have task.run returns a task. So task run. And we'll mimic this exact thing. So it's going to pass in an action or a return value, which doesn't actually return, funnily enough. It's not showing the return value on there, but we can pass in a cancellation token. We'll add these as we need. So right now we will do task.run for just an action. And we will pass in a cancellation token. In fact, we could just go to, if this works, you can do these task.runs here. And then you can do all of them. So you just copy the entire thing. So we've got all of the runs. Oh, and we get the comments as well, which is quite nice. So, although, nope, they aren't correct comments anyway. They're nasty. We will keep the summary. We're going to have to change these though. So, they haven't copied in the correct format. So I will basically move all these comments over like this for each of these, and then skip ahead in the video so you don't have to watch me just fixing these comments. Okay, so that's all that done. All I've done is remove the public static from the start and then moved all the comments into proper summary comments. The funny thing you'll find is the .NET standard comments are actually spelt wrong as well, which I always do. I usually spell cancelled with 2 L's, but it's actually a single one. So we should really report that to the GitHub, that they've spelt it wrong in their task.run. So that's all that done. That's basically a clone of the functions in the task.run that we want to be able to provide. Then we will now make an implementation of that. So again, for now, because we've just got the core project, we'll just make a folder called task. And then here we'll now make the task manager. And then remove that, remove the extra stuff. Public class task manager. And then we'll go into the copy the comment. I'm not going to copy the comments on these because they're all inside the interface. Otherwise it'll get huge as well. For every one of these then, we want to do, we'll make a helper function. So these can be first the task methods. These all go down. Private helper methods. And then in here, we'd want to log the error. So log error. And it would be, again, exception EX. The logger gets the call stack, so we don't need to worry about that. It will find out, where it was called from for us. So we just want to log the exception, which would be ioc.logger.log, and it would be, would this catch? Do we want to catch there? No, it's fine there. It's fine for now because we know it's in the task manager. It's just simply a verbose log that we know it's come from somewhere. All I'm thinking here is that we're going to be, the origin of this log message is going to be this file, not, really any kind of source. But that's fine for the origin. We'll simply pass the details in, or the error log will give us more details anyway about the error, so it should be fine. Each of these functions then would just be, in fact, we would have, these are all tasks. No, not the same. So we've got a task and then a task of T result. So we'd have two. Because otherwise we'd have to try catch on every one. So we'll just say try run. And we pass in the function. And in here, try run, if we did a private task return try run. Private task try run. And we want to accept, oh no, we're going to have to accept every single thing differently. No, okay, so easier than that. It's just going to be wrap everyone in a try catch and log it. So in here we would do an unexpected error occurred running a ioc.task.run, and the error is ex.message. The info is, I don't know whether the class is debug because it's like really low, or whether we want to class it as an actual error, because it depends on if you're expecting an error anyway. So I'm going to keep it as debug, like low level. And then this is if you're hunting for errors, you can find errors by simply logging everything. So logs the given error to the log factory. And I think that's it for there. And then for each of these calls now, we want to mimic the exact same thing. So we want to do try task.run function. Just literally pass it straight into the the underlying normal task.run that we want to run. But then we want to log the error. Try and run the task. Log the error, but then throw it as normal. And the reason we rethrow it is so that, anyone calling task.run, if they are expecting it to crash in a certain way, which we will be, this will, make sure that still happens. So we don't change the flow of code. We simply intercept it, log it, and carry on. And then we can copy and paste this. As much as I don't like copy and pasting, It's probably the quickest way here, because otherwise we'd have to make a helper function that passes in different things every time. And then we just need to make sure we pass in the same parameters straight down and in. And then we'll see this in action, because we'll make it crash to check it does, do its job. And then I'll show you why, in a situation where it will be useful, to show you that it's going to be handy down the line as your application grows, because trust me, when this gets thousands and thousands of lines long, the last thing you want to be doing is searching for a task that's crashed silently that you can't find anywhere. Right, so that's all of them done. So they are basically just calling the normal stuff. We've now got the task manager. IOC, we need to add it to the IOC as a shortcut. So we do that. Task manager, task manager. A shortcut to the task manager. And then in the application, let's just save that. In the application here, we now want to bind to the base factory first, which means the base factory can't make use of the task. Would that ever need to, though? Add logger, remove logger, log. No, because that's synchronous. So you always have to bear in mind as well is in the case of setting up, sometimes the only place you couldn't do it is in the constructors of things that are in the IOC. So like the file manager couldn't say it's this order. The file manager's constructor couldn't get access to the IOC.UI manager because it's not been injected yet. So you just have to think about this order on very first spin up. So I was just making sure the log factory didn't need to do any tasks in the constructor, which it doesn't, so we're fine. So ioc.kernel.bind task manager constant new task manager. Add our task manager. So now we search for task.run anywhere we call it, which is quite a lot of places already. And we want to replace this with ioc.task.run. And make sure we make use of that everywhere. So let's just pin this a minute. Add that. So we've done that now. ioc.task.run. And then we just, make sure we don't do it in the actual call, which is the task manager. So that in fact we only use it in two places, which is one here and one where we were using it. So that's all in and replaced. So now let's show you where it would be of use. So in here, we'll log twice if we through, because this will log it and then pass up, and this also logs in case they're used differently. So let's just go into the app again at the start here, and let's just say this bit of code here, or rather, let's not try catch it. Let's just say we did exactly what we were mentioning before, where we do ioc.task.run, and we were running some kind of task we weren't awaiting. So this now is going to complain, or in fact it doesn't even complain again. So it's not complaining that it's going to run off the thread, this is the whole point I keep mentioning of how easy it would be to get a silent error. So in here you could then just say throw, say this is your code crashing, and oops, so something crashes, and we run this code, and your application won't crash. So if we weren't logging this, you'd be unaware of any kind of issue, and things might appear to be normal, and then ultimately your state is out of sync. So the application spun up, it all looks okay. The only reason it hit there is because I have my exceptions turned on here. So that's the only reason we even saw the that. But in terms of it running in general, this is what you'd see. You'd see nothing out of the ordinary. But if we then go to the folder, our log should have caught that exception. So bin debug. And our log now should say oops in it, which it doesn't. So let's see why. So let's hit this and let's restart. So we get into here. We ioc.task.run. So let's go to task manager, and it should be a action. It should be calling, I think. So we should be calling this one here, unless this is doing some kind of pre-compilation, but we should hit there. Why is this not calling into our? Where is it calling into? So it's getting into the this top one here. So we get there. This should run the function and crash. Which it does. Oh, and it's not even. So that's not quite working as expected. Is this because of how the anonymous action has been run? Because that's not synchronous. That should have caught. That's interesting. So if we hit here, we run. I know why. So slight change there, and that's the key to it, is we're returning the task directly to the caller. So this isn't awaiting. So even though it's a task, we aren't awaiting. So what we need to do is change these to asynchronous, and instead of returning, we await. And that will bring them in line with this thread, and then this thread will catch. So now if we run, and then we'll change that for every function, but that's what we need to do. And in fact, it's not even a function, so it shouldn't have done that one, but there's the throw, and now we've caught it here, which is oops, and then we log it and carry on. So now if we open up the logger, we now have an unexpected error occurred running task.run value cannot be null. Oops. So we log, we've logged the error, and this error would actually say something a bit more specific. We could take this further and have the, if we do the, where's the logger? How we have on here, all these origins, we could get all of those, so we get more info. We could dump them into every function. So we could copy that like so. And we'll do this, because then it gives us, better detail. Then the log exception would have to be file path, or origin file path line number. Like so. We would have to pass all these into the task manager as well, just the same. And I don't think we do defaults though. And again, all this extra work will pay off, ultimately. Once we've done this, let's have a look at the logger, because I know we did something specific to the log factory for make that work. Yeah, that's fine. So what's this complaining about? Put them back in a minute. And then put that back in. Yeah, there we go. So do just copy and paste it into these. So we'll go to every one of these, paste in the caller, and this will give us more detail than we get as well. So we now know where the original source is coming from, not where the log of the crash is coming from, which is always going to be the task. So we chuck them in. Then we will get the comments from the log factory, so they match. And in every one of these, we'll dump even more comments, which go into the param section. And like I say, it might seem like a hell of a lot of work, but this will always benefit you down the line, where it's going to say the first error you ever encounter that's unexpected, this will pay for itself, because you'll have as much detail as you need, almost as if you're debugging locally. So we do that for every task. We change everyone to await instead of return. Make our log error have the same stuff. Have even the same comments for those again. And here, the exception to log. And now in here, we can then pass in the new origin, file path, and line number. So it passes through from the original caller. So we can test that first on 1, which is this one now. Oh, we can't until we've pasted this into everyone. So they match the interface again. And then we'll come back and add the, the return, the await statements instead of the returns. But let's just check this works first. Right, so now we should be implementing the interface again. We run, we should get a crash log, and this time it tells us that it should have come from this ioc.task.run, funnily enough, which wouldn't boil up to startup because we just run it inside, but typically this would have been, you wouldn't do this, you would have been running inside of a task already. In fact, now that's the point, you'd have been running in there all the time. So we might have to bake that further up. So now an error occurred oh, there you go, it has caught it. So it's bubbled up to now the appsaml on startup call instead of the task manager.log error. So now it's a lot more specific. We now know the error come from line 33 and on startup in appsaml. So it come from exactly here. Technically it's come from the run, the thread, but that's enough. It's got us to the line of code where it's starting. It's even got us the function name that it's inside of. So that's the information we need. So now when something crashes, we know exactly where and why for, and the date and time. So I think that covers file logging. You can go further and potentially turn this into a markdown file. So I don't know how long we've been running for, but we could fairly easily add a markdown file logger or even a flag to turn it into markdown style. But we'll, we won't do that right now. You don't really have a markdown log file. A log file is typically just text dump. But that's the file logging done. So again, now anywhere we do a log, it can log to file. So hopefully that was useful. Next video, we'll probably now look at exception handling, catching all these exceptions, doing the to-do for application settings so we can start storing settings, moving into some JSON synchronization, serialization rather, and basically, again, getting this application ready for being complete when the server's done. So all this growth and all this IOC and all these managers and things are the preparation work to get this application, ready for all that. So again, any comments, let me know, but hopefully this has been another useful video.